Hello and welcome. In this video, we are doing the IEB exam question 2018, uh, question 2. So we're given a sigma and it is a sum from n equals 1 to x. So we don't really know what x is. I do suspect we're going to be asked to find that eventually. And the expression is this: 108 times 2 over 3 to the power n. And the first question is asking, determine the first two terms. As always, I recommend you do this yourself first before we do it on the video. You can pause the video and try and do that for each question. Okay, so the first two terms, that would obviously mean that you are just substituting from the bottom number, which is 1. So substitute T1 would be 108 times 2 over 3 to the power of 1. That's the first number. And then that is equal to 72. T2 would take the same expression, but rather it will substitute 2, and that would give 48. And that gives you the first two terms, so that's pretty simple right there. You do get that 2 marks pretty simply for question 1. Question 2 is a little bit more than the first one. So here what we're being asked is if we know that the very same sum, sigma notation that's given at the top there, if we know that it's equal to 520 over 3, then what would be the value of x? So this obviously would need us to evaluate this sigma, and after evaluating it, then we will be able to equate it to 520 and solve for x very, very simply. And this is obviously understanding that we need to use this formula here, Sn formula, which is equal to 520 over 3. We need the Sn formula to equal 520 over 3. And the Sn formula, as we know it, is a r to the power n minus 1 divided by r minus 1 equals to 520 over 3. And we need to solve this. Obviously, we must substitute a, which we know is just the first term, and we've already done that right here. That's the first term, t1. So that's going to be 72, and r is just going to be found by dividing this by the previous term there. And that is simply just 2 over 3. So you can just put the 2 over 3 in the place of r, 2 over 3 to the power n. But you can sort of realize as well, instead of n, maybe at this stage you can just change, instead of writing n and put x. And the reason this is not a problem is because this sigma does start from 1. And if it starts from 1, we can always just say n is equal to whatever is at the top. And that is x in this case, which is what we're trying to solve anyway. So I think that's best that we do that. And then we've got at the bottom, we'd still have 2 over 3 minus 1. That's equal to 520 divided by 3. And continuing to solve this is now just a matter of algebra, which we can do. You have to multiply, you have to find out what this number is, and you have to divide by 72 afterwards on the other side. After you've multiplied this number there and divide by that one and add 1, and you really should be, after you've done all of those steps, you should end up with 2 over 3 to the power x is equal to 16 over 81. And when you do end up with this, it does seem to appear that you can prime base each number on the right. So if we just go to the right there and say 2 to the 4 is the same as 16, and 3 to the 4 is the same as 81. So we've got this, and this is pretty nice. Luckily, these have the same exponent, meaning we can rewrite them as just 2 over 3 to the power 4 like that, allowing us to say, therefore, x is equal to 4. Of course, one of the other ways you could have done this at this very step is you could have just said x is equal to log base 2 over 3 argument 16 over 81, and that would have given you x being 4 as well. So you could have just used the log. If you didn't recognize it, you could do this, and that would have still been perfectly fine. So that's that question. I think that's a pretty simple question. I wanted us to try another question as well, just to part B, which is another different question that I think is interesting. So here we've got a hollow plastic hemispheres are created such that successive one fits into the previous one. So this fits inside that one, this fits inside that one. And the radii OB, OB is just that part, is 21. So I'm just going to label that with a real pen. So that's 21. Um, and OD, which is the next one, is 3. That's the radius there. And OF is 3 over 7. And quite clearly, you can see that from 21 to 3, you definitely divided by 7. And also from 3 to the next number, you can see you divided by 7 again. So this is seeming to be a multiplication by 1 over 7. As division by 7, it's the same thing as multiplied by 1 over 7. Now let's get what we're trying to do here. Determine the sum of the outer surface areas. Okay, outer surface is sort of these gray areas that are shaded, outer surface areas, as shaded in the diagram, of all such hemispheres created by continuing the pattern indefinitely. So if we just continue the pattern indefinitely, we can find exactly what the sum is going to be in if we were to continue this pattern indefinitely. This is obviously a sum to infinity question because you're continuing indefinitely, and you will see the ratio as well is also between -1 and 1. You're also being reminded that the surface area of a hemisphere, this is the good thing about this, is that you will be given a formula if it's a shape that you have to know the formula. The formula will be provided for you, and this is the formula provided, 2 pi r squared. It's the surface area of a hemisphere. Okay, so each hemisphere has got that surface area. So for the first one, because usually you need the first 3 terms, I mean, it really does help to do that. And so let's do the first 3 terms for the surface area here. So we've got the first one would be 2 pi radius 21 squared. And the next one is 2 pi radius 3 squared. Next one is 2 pi radius 3 over 7 squared. So that's really the areas of the first 3 hemispheres that we're looking at. And if we take uh, uh, r, which we can just take t2 over t1, just so we can know what the ratio is. I mean, t2 over t1, not t1. t2 over t1, that's going to be 2 pi or 3 squared divided by 2 pi 21 squared. And that's the 2 pi's will cancel each other, and that's going to be just the numbers, and those simplify to 1 over 49. And that becomes r, and that's that's a very small r, and we can see that's in between -1 and 1. So that means this series will indeed converge. So if we want to find the sum to infinity, it would be a over 1 minus r, and this is a of the first term, which is over there. That's the first term. Um, and you've got that this is going to be 2 pi 21 squared divided by 1 minus 1 over 49, and that means s infinity is the same thing as, if you put that in a calculator, you'll get 7,203 over 8 pi, and that rounds approximately to about 2,828.6 centimeters squared, because that's the surface area. So we created a sequence of surface areas, only the surface areas, not the radius, not the radii, but rather the surface area, because the question is actually interested in the surface areas. And we did find this sum to infinity. So if this was to be continued indefinitely, we know for sure that this sum will not exceed this number. And that's that question over there. This is a bit of a longer video, but I hope that you did catch a few things in this video, and I hope that you also tried to do the questions yourself before watching the rest of the video. Oh, I do see I was trying to mark in the first question there, but the rest I really didn't mark. But at least it does give you how many marks there are. I'm not going to be marking because I just think that that's going to take too long in the video. So thank you so much for watching. I'll see you in the next one.